a fourth period.
No, it's just because I totally forgot. And it's for Nora. She's one of us, okay?
Yeah,
She's in our family.
She's gonna give labor because she left.
Huh?
She said she was gonna give the labor in like next week or something.
Yeah.
Or
Verse.
early. Before spring break. Or during spring break.
Give labor.
Give labor. I don't know why I said that. I just kind of saw her leave and I was like, oh my God.
Yeah, no, she asked me to record it. Okay, what are you doing on this? What are your shapes, I wonder?
A triangle.
Okay, big triangle,
Mini triangle.
little triangle. Now, oops, should I have gone that far?
No.
Oh, the disadvantages to a pen. Not this one. Okay, just the little baby one. How big is the one on top?
I got 10. Well, I'm not sure.
10. How big is this one?
I did
1.
1.
10 minus 1 is 9. Okay, G prime of 3 would be F of 3. What's F of 3? 1, 2, 3. Positive 2? Negative 2. G double prime of 3 would be F prime of 3, which is the slope. What's the slope of that line? Negative 2. Very good. Okay, part B. We want to know on what intervals is G increasing and concave down. They are giving you a specific sign for G prime and G double prime. If I want G to be increasing, what do I want G prime to be?
Greater than 0.
Positive. And what do I want G double prime to be for it to be concave down? Negative. Now remember, what characteristics are those in the graph though?
The y value.
Okay, y value here, slope here. So find the intervals where you have a positive y value but a negative, so don't say that loud. There should be 2 chunks of your graph.
Oh, yes.
Positive y values but negative slopes. Okay, where's one of my intervals?
Negative 5 to 2.
Okay, good, right here. Negative 5 to negative 3, right? So negative 5 to negative 3, union, we have one more.
And then 0 to 2.
0 to 2 would be here. Very good. Okay, make sense?
Yes.
Okay, then I would put because G prime of x, which is f of x, is greater than 0, and G double prime of x, which is f prime of x, is less than 0. Okay? So that would be your explanation right there. Boom, boom, boom. Okay? Alright, part C is a little weird, but we're going to review it because AP test is only a few months away. Okay, h of x is, this is part C. H of x is g of x over 5x. And they are, oops, that's an x. Okay, and it says to find h prime at 3. If you have h of x and you want h prime of 3, what do you need to find before you find h prime of 3? You need to find h prime of x. So we need to find h prime of x first.
Wait, what is that? X to the 5.
That's an x. I started to make a parentheses and then I tried to turn it into an x. Okay, clearly that did not work. Okay, what rule do you need to take the derivative of that? Quotient rule. Okay, set it up on your paper. Remember, you have your top function and then you have your bottom function. Then you take the derivative separately. So what's my high?
G of x.
What's my ho?
5 of x.
5x. Okay, what's d high? The derivative of g of x.
Prime of x.
Okay. And what is the ho?
5.
Okay. Then remember, it's ho d high minus high d ho. So ho d high would be 5x g prime of x. Minus in quotient rule.
5.
And then high d ho would be g of x times 5. But the order there doesn't matter. Then divide by ho squared, which is 5x squared. Okay, now let's find h prime of 3. So right above that, okay, 5x. What's x? 3. So 5 times 3 is 15. And then I want g prime of 3. We'll go back to part A.
Oh, we found that already.
Yep, because I added it into the question. What was g prime of 3? Negative 2. Okay, minus 5. And then next we want g of 3. What's g of 3? 9. Divide by? 15 squared. Do you have to do any more than that? Nope, that's good enough right there. Okay? So remember, you would need quotient rule, and then your letters, your G and stuff like that, you'd have to use your chart to find. Okay, part D. Part D says P is defined by, I'm going to write that out, P of x equals f of x squared minus x. Find the slope. What's a slope if you have an equation?
The derivative.
The derivative. I want the slope of the line, the derivative of P, at negative 1. What am I going to do? Take the derivative, plug in, negative 1. Now, did it say for me to find the equation of the tangent line?
Oh,
No. If it did, though, you could do that, but unnecessary work if you don't have to. So if all I want is the slope, then my goal is to find P prime of negative 1.
If you don't, never mind.
Now, if you wrote the whole equation of the tangent line, you wouldn't be wrong. You'd just be doing a bunch of extra work you don't need to do, right? Okay, so when I take the derivative of this, do I need product, quotient, or chain?
No.
It is chain. Why is it not product?
It's minus.
Yeah, because all of this stuff is inside f of x, right? It's not f of x times that. That's in the middle. So when I take the derivative of this, I'm going to need to use chain rule. Okay, so P prime of x equals. We're about to do some of this when we do chain rule on our packet you picked up. Okay, outside first. What's the derivative of f called? F prime. Do you change the middle right away? No. So you do f prime, and then you keep the middle the same, but then for chain rule, you multiply by the derivative of the middle.
Yeah, 2x.
So what's the derivative of that? Just 2x?
2x minus 1.
2x minus 1. And then what are we plugging in?
1.
At x equals negative 1. Very good. So let's plug in our negative 1 in here.
We want to multiply by 2 again.
Because it's just this in the middle of that. You don't keep taking the derivative all the way down. You just take the derivative once, unless it's like an extra layer. So like if it was this, y'all don't write this, but if it was like e to the sine of 5x, then you have e as a function, sine as a function, 5x as a function. That one you would have to take the derivative an extra time. But if it's just f and then a function, you only have two things. So you do outside then inside. Okay? Okay, so I want f prime of, plug in a negative 1 here.
1
Okay, positive 1 and then what?
minus 1 is 0.
Minus negative 1.
2.
Yeah? So if I have negative 1 squared minus negative 1, right? That's going to be positive 1 and then plus 1 more. That's a 2 in the middle. Okay, times? Then I'm plugging in my negative 1 here. What's 2 times negative 1? Negative 2 and then minus 1 more?
3.
Negative 3. Where am I going to find f prime of 2? In the graph. Okay, so look at your graph. At 2, what characteristic will f prime be?
So,
A slope. Very good. Okay? Now, if it was g prime, it'd be the y value, but it's f prime, right? Okay, so look at your graph at 2. That's this same line segment here. What's the slope of that line? We already found it. Negative 2. So it'd be negative 2 times negative 3. What do we get?
6.
Positive 6. Good? Okay, great. So go to your new packet, and we're now going to learn the chain rule of this. Okay? This is 5th period. Okay, at the top of your paper, put the derivative of the integral, just like we did last time. Derivative of the integral. And then instead of integrating from 0 to x, so d dx, you're going to integrate from a to u, where u is going to be like something with an x in it, okay?
Like a constant.
No, so like look at this one. See how it's like a 6x?
Okay.
Or like a 9x squared, or like a 2x, something like that, okay? So what is the antiderivative of little f?
Big.
Capital F. Then which of these would I plug in first? F of u minus f of a. Okay, what's that? That's your fundamental theorem of calculus, right? You take the antiderivative, plug in the endpoints, and subtract. Okay, then from here, I need to take now the derivative of that. Okay, so let's talk about the constant first because it's easier. F of a is a constant, yeah? Constant. What's the derivative of a constant? That's going to zero out and go away. The reason that chain rule is different is when you take the derivative of capital F, what do you get? Regular f of u. But then for chain rule, what do you have to multiply by? The derivative of u, which would be u prime. Okay? So you take your antiderivative, get capital F, plug in your endpoints. This is a constant, so when I take the derivative, it goes away. But then right here, this is where you need that chain rule step. Okay? And you'll multiply by u prime. Now, as far as actually doing these questions, it's really not very hard. Okay, so look at number 1. What is my u in this case? What's my upper boundary? It's not just an x, it's a 6x. So when I plug in, I'm going to plug in a 6x and get the secant of 6x. But then I have to multiply by the derivative of 6x, which is 6. Okay? Yep. Yep. Now, obviously, when you put it in like a graph, it'll be a little harder, but not much. Okay, so look at number 2. What are we plugging in? What's our u? 9x squared plugs in right there. So I have 9x squared times 4 is now 36x squared. Okay, then I have to multiply by the derivative of my u. Remember, u is that. So what's the derivative of that? 18 what? X. Good. Okay, next one. What's wrong with number 3?
Wait, how'd you get 18?
The derivative of 9x squared.
Oh.
Yeah? Okay, so what's wrong with the order here? Yep, so how can I fix that? Put a negative in the front, and then you can reverse the order so that the 2x is on top. Okay? So if your order is backwards, you just apply a negative to the front, and then you get to use that rule once you switch it. So the 2x is going to plug in. What is my cosine now of? Okay? Cosine of 6x. Now, this is important. You are not timesing by the derivative of this. You're timesing by the derivative of the end point. So what am I multiplying by in the front? 2. And there was already a 4, so now it's an 8. Also, negative. Yeah?
Could you like write -2 times 1?
Sure. I mean, if it was free response, if it was multiple choice, they probably wouldn't write it like that. Okay, number 4, we're going to do this one tomorrow. Y'all don't let me forget. Okay, but I want to at least get through the first FRQ. So go down to number 4. This is just like on your homework number 7. Okay, so you have an equation. F of x equals the integral from 1 to 2x of 6t minus 1 squared dt. Now, in a second, we're going to take the derivative. Okay, but first, we're going to find f of 2. So what will I do with 2 if I want f of 2?
Plug it in.
Plug it in where?
Or the x.
The x. So where is my integral actually going to be from when I find f of 2?
1 to 4.
Okay, good. So integral from 1 to 4, and then 6t minus 1 squared dt. What method will you need to integrate it? My cheesy dad jokes. Okay, did not make it for you. Okay, so t minus 1, then what's the derivative of that? 1 dt, which means dt is what?
du.
Just du, right? If it's a 1, that doesn't change anything. So now we're going to rewrite our integral. What do we have to remember to change? Endpoints, very good. So my integral is now going to be a 6u squared. You remember this? So that's my u now squared. And then my du and my dt are the same. But then I have to remember to change here and here. How do I get the new numbers? Good, plug into there. So if u is t minus 1, I used to have a 4 on top. Now it's a 3. What about 1 when I plug it in? 0. Okay, antiderivative of 6u squared. You have to add to the power. So now it's what? U to the third with a 2 in front. Then what am I plugging in? F of 3, f of 0. Yeah?
I'm actually so confused right now.
Okay, can you tell me where? So we did the antiderivative. So we added 1, got u cubed, then divided by 3 and got the 2. And now we're plugging in our endpoints. So what is 3 cubed here? 27 times 2 is? Okay, plug in 0. 0, then subtract? 54. Now question, could you have put this 2 on the outside of the box? Sure, you would have gotten the same answer. Okay? Remember how to do that? Okay. Alright, go to part B. Now I want the derivative of capital F. What do I do with 2x? So 2x is my upper boundary. Yeah? Okay, I'm going to plug it in where t was, and then what do I have to multiply by in the front if I'm taking the derivative? The derivative of 2x is 2. So f prime of x is going to be a 2x plugged in here. So 2x minus 1 squared. And then I have to times by a 2 in the front.
Could you repeat that, please?
Uh-huh. So f prime, so pretend like this is written down here. What I would have written first is f prime is the derivative of f, yeah? So I would have the derivative of the integral from 1 to 2x of 6t minus 1 squared dt. And then this is where you're using that rule that we just learned. So you would take your 2t here, you would replace it right there. So do we see now why that's a 2x minus 1?
Yeah.
Okay, and then what's the derivative of 2x? 2. So capital F prime of x, I'm going to write here in the middle. 2 times 6 in the front is going to be a 12. 2x minus 1 squared. Good to there? Okay, how am I going to find f prime of 2 then? If this is f prime of x, what's f prime of 2? What do I have to do?
Plug in a 2.
Plug in a 2. Okay, plug in a 2 right there. What's 2 times 2? 4 minus 1 is? 3 squared is? 9 times 12. So 9 times 12, and I'm just going to leave it like that. Okay, for your response. Okay, and then I'm going to put right here, all that we did was plug in x equals 2. Okay? Alright, next one. Now I want f double prime. Okay, what rule am I going to need to use if 2x minus 1 is all squared? Choices are product, quotient, chain. Chain rule. Let's do f double prime. Ready? Okay, what do I do with my exponent? Okay, what's 2 times 12 in the front? 24. What's the new power on 2x minus 1? It used to be squared. Derivatives, I take 1 away. So now it's to the 1. You can put that or not. Doesn't matter. And then times by the derivative of the middle. What's the derivative of 2x minus 1? 2. So what is f double prime going to be?
48.
48 in the front. 2x minus 1. Okay, what rule did we need to use in that one? Chain rule. Okay, good. Alright, now, next part I want f double prime of 1. Well, then what are you going to do? Yeah, if I already know f double prime of 1 just means I need to plug in x equals 1. So in there, what would I get if I plug in a 1? Okay, I'd get 1 times 48 is 48. So far, so good? Okay. We have just enough time to work the next free response.
Is
Okay? Yeah. Huh? You think so too? You don't think we have enough time since all my clocks are broken? No. Enough.
I have to go, so.
Enough of this foolishness. Okay. Look at your next graph. Okay, question. How would you have known, just looking at the question, not doing any of it, how do you know that you're going to need chain rule?
The 2x.
Okay, yes, look right here. Is it the integral from 0 to x? 0 to 2x. That 2x tells you when you take the derivative, you're going to need chain rule. So I'm going to start right up here. And the first thing that I always do on these questions is go through g, g prime, and g double prime. Let's do g first. So it's integral from 0 to 2x, f of t dt. How am I going to find that if this is a graph of f? Remember what we've done the last 2 days? Area. Okay? Alright, next we want to take the derivative. So I want g prime of x. Okay, well if I want the derivative of the integral, what do I do with the endpoint? Plug it in. So instead of being f of x, what is it now? 2x. And then what do I have to remember to times by chain rule? Of 2x, which is 2. So far so good? Okay, now we need to find the second derivative. Okay, look just at the outside function. This is where your chain rule is going to come in. What's the derivative of f called? F. That's antiderivative. We want derivative. So f prime of 2x times by the derivative of the middle. What's the derivative of 2x? But I already had a 2, so what do I put? 4.
What do you mean you already have 2?
So I already had a multiply by 2 from my first chain rule. So when I chain roll again, I have to multiply again by that 4. Does that part make sense so far?
Did we not do that on the...
No, because this was always just an x. So then when you take the derivative, you just got f of x, and then you just got f prime of x. So the only difference is that instead of it being an x alone, now it's a 2x. Okay? So let's do part A, and then I'll have you do part B. Okay, ready? Part A. I'm going to do it up here. Okay, I want g of 1. When I integrate, I'm plugging in 1 right here. What am I going to have when I shade? 2. Very good. When you integrate, you're plugging your 1 in for the x, but that x gets multiplied by a 2. So it's from 0 to 2. So on your graph, you're not only shading to 1, even though this is a 1 here. You shade from 0 to 2. What shape is that? Triangle. Area of the triangle, 1/2 base times height? 2. Okay. Next we want g prime of 1. I'm going to copy this formula exactly, but where am I going to plug in my 1?
The x.
For my x. So where do I really want f at? F at 1? F at 2 times 1, which is f of 2. Then what am I going to times that by after I find it? A 2. Look at your chart. What is f of 2 in the chart?
0.
Okay, 0. How'd you get that? That's the y value. So this is the y value. So if I look at 2, 2, 0 is right here. That 0 times 2 is 0. Okay, next part. We want g double prime at 1. Okay, well look at your formula right here. When I plug in my 1, where am I going to have f prime at? 2 times 1 is f prime at 2. And how am I going to find that in the graph? Slope. What am I going to multiply it by at the end? 4. Times 4. So at 2, what is your slope? But it's downhill 2, so it'd be negative 2 times 4 is negative 8.
I still don't get how you get 4 for the G double prime.
Okay, so I want y'all to do part B, okay? So look, when you're here, when you take, so y'all do part B, you're finding the same 3 things at negative 2 this time. So when you take the derivative of f, you get f prime. keep the 2x the same, but then you have to times by 2 on the outside, because what's the derivative of 2x? So you already had a 2, times by now another 2, now it's a 4.
So you have to look back like the previous and then see if this constant and then you have to add
Yeah,
that
because you're taking the derivative of this. You're not taking the derivative of just that. That 2 is a part of g prime. So when you take the derivative, whatever the y value was, in this case it was a 0. But if it was like a 1, you would have had to times that by 2. That make sense?
Yeah, that's not a trapezoid.
So it's a triangle and a trapezoid put together. So you'll have to break it up. Okay, you will have to split when you shade up. You'll have to split that up into 2 shapes. Okay, what should I put here as my upper boundary? Is it a -2? -4, because why? Remember your 2x? So if this is a 2x here, when I plug in that -2, I'm really going to integrate on my graph all the way back to 4, yeah? So -4 would be all the way back to here. And then I'm starting at 0, so I can go ahead and shade this whole thing. Okay, but I'm going to stop when I get to there and shade in a different color, because what 2 shapes do I need to find? Okay, that green is a triangle, that pink is a trapezoid. Did anybody find the area of the trapezoid? Okay, 15 halves for this. Okay. Ooh. Yeah, it should be, so look, your base 1 is 3. That's 2, and then it's only 3 wide. Because remember, you can't count this as part of your trapezoid, yeah? So it would have been 1/2, I'll show it over here, 1/2, 3 plus 2 times 3. So that'd give you 5 times 3 is 15, divided by 2. Okay, now what about my little triangle right there? Okay, 1 times 2, cut it in half is 1. Now, when I add those together, 15 divided by 2 is what? 7.5, so plus 1? 8.5. Okay, should it be negative or positive? James, why positive? Because it's backwards. So you're exactly right to think, oh, it's below the x-axis, that's 1 negative. But then what is your order? Backwards puts another negative on it. So 1 negative is from it being below, the other negative is from it being backwards. Okay? So it's actually going to be positive 8.5. Okay? Sure. Okay, second part, we want g prime of -2. Well, using my formula here, that would be f of what when I plug in a -2? F of -4 times by what? 2. What is f of -4 in your graph? -3 times 2 is -6. Okay, then g double prime at -2 would be f prime at -4 times the answer by 4. So f prime at -4, what's the slope of that line segment? 1/3 times 4, which is? It is, yeah. So, but what's, this would be 1 1/3 or just 4/3 to keep it easy. So yeah, you'd go up 1 and then over 1, 2, 3. Because remember that first 1 doesn't count because it's not in there.
I got sick brain, that's all.
Oh. Okay, this is where it's going to get like a little confusing. Okay, so stay with me here. Okay, look at your graph. Where are your critical numbers? Where what happens? Where your graph crosses through, right? Okay, so put dots on your critical numbers. Where should I be putting my dots at?
0.
0, and 2. What type is 0?
Relative.
Min or max?
Max.
So it's negative values to positive values. That'd be
Okay.
negative to positive is a min.
My brain doesn't work too.
That's okay. We have another day of it. Okay, and then over here, what will it be?
Max.
Max. Okay, here's where it gets a little bit confusing. Okay, so are we all on the same page that this is a min, that's a max? Okay, so you want to write, okay, well my min happens at 0, my max happens at 2. Here's the thing that you have to remember. If I pick that x is 2, remember, there's a 2x here. What is that going to be on my graph? What x value? If I put a 2 here. 4. And is that where my max happens? No. So what you have to do is think backwards and think, okay, whatever x value I pick, I'm going to have to double it when I put it next to 2. So if my max happens at 2 in the graph, what x would I have to pick so that 2 is the final answer? 1.
Wait, huh?
Okay, so I'm going to say it one more time. Okay, the x that I pick has to give me 2 when I plug it into 2x. So I would have to pick for x to be 1. Now, question, on the 0 one, does it matter if I times it with a 2? No. So I'm going to write it out, and then I'll try to explain it one more time if you don't get what I mean. Okay, so come down here. So in my graph, x equals 0 is a critical number. Okay, and it is a relative minimum. Because g prime of x, which is f of 2x times 2, changes from negative to positive. Okay, let's write the second one, and if you're confused, just write it down first, and maybe this will help. Okay, I'll get it written down. Okay, so I'm going to try one more time, and then we're going to do another one just like this, and hopefully it'll make more sense. Okay, where does this switch signs at? 2. I am picking 1, because when I plug in 1 to 2x, what do I get? 2. Okay, now look at your graph. Find your point of inflection. Point of inflection happens when the slope changes sign.
1.
Okay, so I have, what's my slope here, positive or negative? Positive, then positive till when? 1, and then what happens? Negative. So on the graph, where's my point of inflection?
1.
1. But I have to pick an x so that when I times it by 2, I get 1. So I have to divide by 2 to undo the times by 2. So what am I going to pick? A half.
And so the reason we don't include that other times 2 is because
Because it doesn't affect the sign. Yeah. So a positive times 2 is still positive. A negative times 2 is still negative. So he brings up a good point. He said, why don't we care about that too? Well, because think about, when you're multiplying by something, that doesn't change the sign. And all we're worried about is the sign. So if there's a number in here, if it's a times by 2, you divide by 2 to undo it. And what if it was a divide by 2, what would I have to do? Times by 2 to undo it.
So just set the whatever in the parenthesis equals to the numbers on the graph.
That's another good way to do it. If you let 2x equal 2 and you divided, you'd get 1. So for my very analytical people, that might make more sense. Okay, if I want 2x to equal 1, what would I pick? X is a half. That's great.
But why do you want it to equal 1?
Because at 1, what happens to my slope? Changes sign. And what's the slope in this graph? The slope is g double prime. Yeah? So POI, because g double prime of x, which is f prime of 2x times 4, changes sign. Okay, I'm going to adjust this next question, put a prime on there. Okay, what is g prime in my graph? The y values. Now remember, are they the y values times by 2? Yes, but does the times by 2 change the sign? No. So what do I want my y values to be? Less than 0. So look at your graph. When are your y values less than 0? -4 till 0 and 2 till we have to stop at 3. So let's write down here on my graph. I have negative y values from -4 to 0 and from 2 to 3. Now, what is that forgetting about? The 2x. So the x's that I pick have to be half of each of these x's so that when I times it by 2, I get these numbers. What x would I pick to give me -4 when I plug into 2x? -2. What would I pick for 0? 0 times 2 is still 0. Very good. Okay, that's my first one. Union. What x would I pick so that 2x is 1? 1. And then what x would I pick so that 2x is 3? 3 halves. 3 over 2. Does this help if we write it like that?
Yes.
Okay, good.
I created that.
And then look, watch. We're going to cross this out. Okay, because remember, they're asking about G and my graph is of F. So because of that 2x, it kind of fuddles things up a little bit.
Okay.
Okay? All right, we're going to stop there. Okay, we have another one of these to do tomorrow to help you get caught up. So, great. Good. Good job. Okay? And I do not think the one on your homework, the big FRQ, is not for your spot. It is not chain rule.
Wait, join the 2x.
Why didn't you say that multiplying by the other two doesn't change the sign, but then you minus it?
Yes. So whenever these values change sign, will timesing by 2 mean that it doesn't change sign there?
No, but it would make it 4.
What do you mean?
Like, you know how you have to make this 1 and not 2? So it's an n. But if you multiply by 2, you get 1 and still 2.
So if you multiply 1 by 2, you get 2.
And multiply it by 2 again.
But remember, when you multiply by 2 again, that's not affecting what x you pick. You would just take whatever positive number you get and times it by 2. So if I have a positive number and I times by 2, it's still positive. If I have a negative number and I times it by 2, it's still negative. So that's why this second number back here, right here. That's why that
You know me.
second 2
Always
there
says the
doesn't
last
change.
minute.
Because timesing by 2 isn't going to mean your graph didn't change.
Or
It's still good.
student, at least I got it done on time.
That makes sense. So
The
like,
whole thing?
if it's a half x, x over 2,
I can see ya.
then like let's say we wanted to put 1. Well then what would I do?
So where did
1
you
so
skip
that if
this
I
one?
cut it in half, I get 1. Now think about it, I have a double addition because it's a half. Versus here, I have a double in the parentheses. So to undo it, I have to. What if it was a times by 3?
Except for your name, because I know your name, so I can read it.
Undo that. Does that make sense? But we'll do one more like that tomorrow.
Join up for the 2x equals 3. Do you plug it in?